For example 5, we want to find the vertex, the focus, the equation of the directrix. We want to also graph this equation. One thing that we notice about this one is not in standard form. Alright, when we look at this equation, we do see that we have an x squared, and y is not being squared. But we also notice that we have an x to the power of 1. We don't have the parentheses. This does not look like the standard form. What's the standard form if we're looking for x being squared and y not being squared? What we want the equation to look like is x minus h squared equals 4a times y minus k. So if x is being squared and y is not, we want to make our equation look like this. So our goal, if it is not in standard form, is to put it in standard form. Okay, and we're going to talk about how we do that. Okay, the first step is to look for what variable is being squared. So that's x squared. We want to keep anything that has an x in it on the left-hand side. So I'm going to keep x squared and 6x. Anything that doesn't have an x in it, so anything that doesn't have to do with the variable being squared, I'm going to move to the other side of the equation. Okay, so that's step 1. Identify what variable is being squared. Keep that family of variables on the left-hand side. Okay, and I'm going to put a little blank here, and we'll see why in just a minute. I want the quadratic term, the linear term, and I'm going to put in a constant term in just a minute. So plus a blank equals. Now what happens when I actually move those terms to the other side? Well, you actually have to subtract them or add them depending upon what their sign is. So we're going to do the opposite sign. So those go away, cancel each other out. On the other side, we end up with a negative 4y minus 17. Right. Our second step is a process called completing the square. We're going to complete the square. Completing the square means that you're going to look to the number that's in front of the linear term, and you're going to take half of that. Okay, what is half of 6? So positive 6, divide that by 2. That's what we do when we halve something, we divide it by 2. Positive 6 divided by 2 is a positive 3. We're going to half it, and then we're going to square it. So what is a positive 3 squared? That's a positive 9. Now, I just made a change to the left-hand side of this equation. If I make a change to the left, I also have to make that exact same change to the right. So I'm not only going to add that 9 to the left side, I'm also going to add exactly that same 9 to the right side. Okay, step 2 is called completing the square. We're going to half the number in front of the linear term, then we're going to square it, and that's going to go in a blank on the left side and also on the right side. We've got to keep the equation balanced. Alright, step 3 is to factor. Okay, what do we mean by factoring? Well, we're going to take these 3 terms that we just put together on the left-hand side, and we're going to factor them. So that would factor as x plus 3 times x plus 3. And a better way of writing x plus 3 times x plus 3 is x plus 3 quantity squared. Now, if you want to, you can check that factorization, so you can multiply that out, see if it's correct, but it's correct. But we get x plus 3 parentheses quantity squared. That is how that factors. Now you'll notice also that this, the left-hand side, now looks like the form we want. We wanted x minus h quantity squared, and now that's what we have on the left-hand side. So we're looking more like the standard form. Okay, now on the right-hand side we have to do something as well. On the right-hand side we're going to combine the like terms. So negative 4y, we have minus 17 plus 9, that gives us a negative 8. Alright, and then we're going to factor out whatever number is in front of the y. When we look up here, we have a 4a, and then we have the y in the parentheses. We don't have any number in front of the y in the parentheses, so we want to get rid of any number that's in front. And when we do this, the procedure is to factor it out of both terms. So if I'm going to factor out a negative 4, I'm going to divide it out of both terms. That negative 4 comes to the front, and then what's left is a positive y, because negative 4 divided by negative 4 is a positive 1y. Negative 8 divided by negative 4, that's a positive 2. So you want to be careful with your signs if you factor out a negative. Alright, so now we see that the right-hand side now fits the form of what we have up here in our standard form for that equation. So now we can find a few things. Here's the standard form. Now we know what the vertex is, right? The vertex then would be negative 3, comma negative 2. We should be able to determine what's the focus, and then what's the equation of the directrix. Alright, so let's start to graph some things. I'm going to label my graph. Alright, so our vertex is negative 3, comma negative 2. So we'll plot that. I'm going to go ahead and label that with a V. What is the orientation of this parabola? Alright, x is being squared and y is not, so the parabola either opens up or it opens down. Okay, so if x is being squared and y is not, and both sides are positive, then the graph opens up. If one side is negative, then the parabola opens down. Alright. And we said there's a few different forms of this that we might run into. These are all the same thing. Now when I look up here in my equation, we know that the graph is going to open up or down because x is being squared and y is not. But if I look at the sign in front of the focal width, that's a negative sign on one side of the equation. That's actually going to flip our picture upside down. So this is the picture that we're looking for. That also implies that our axis of symmetry is vertical. So our axis of symmetry is vertical. Okay, that's going to help us draw our graph as well. Okay, so since I know my axis of symmetry is vertical, I'm going to draw a vertical line going up and down. And remember that on this line, we have the vertex and the focus. Alright. Where is our focus? To figure out the focus, we would need to know the distance of A, right? We need to know the A value. The number in front of that parentheses is our focal width. That's the negative 4. Remember, that is the 4A. So to solve for A, say negative 4. Oops, let's do this. Let's say 4A. So that's the formula for the focal width is equal to the number in front of that parentheses. That's negative 4. So let's solve for what A has to be. Divide both sides by 4. We get A equals negative 1, or I don't care if you say A is a positive 1. The important part is we get that number. We get that distance. Okay, so we're going to go up and or down to plot our focus. Now, which is it? Is it up or down along that axis of symmetry, 1 unit? Well, we said that our picture was going to open upside down, and we know the focus always lives inside. So the vertex would be above the focus, and the focus would be inside, below the vertex. So we're going to go 1 unit down and say that's our focus. So 1 unit down, living on the axis of symmetry. So what point is that? Was that -3, -3? Okay. Here we go. What about the directrix? Well, the directrix has to go in the opposite direction of the axis of symmetry. So if the axis of symmetry is vertical, then the directrix will be horizontal. And we know that it's 1 unit away from the vertex. So our directrix is actually up here. So what's the equation of that directrix? That would be y equals, so every time you graph a line or give the equation of a line that's horizontal, the equation is always y equals a number. What's the number of the y value on that line? Well, it looks like it's -1. Okay, so we have the equation of our parabola, we have the vertex, we have the focus, we have the directrix. If I want to graph this, then I'm going to need to figure out what are the points on the focal width. Okay, how wide is the focal width? Well, the focal width is the number in front of that parentheses. It's that green number, it's the 4. If you want to think of it as -4 or +4, it doesn't matter. But it has to be 4 units long. So we're going to go to the focus, and I'm going to go to the right 2. Remember, we want to go to the right half and to the left half. So all the way across from point to point on the parabola has to be a total of 4 units wide. Can we label those, right? What would that be? -1, -3. And is that -5 for x and a y value of -3. Alright, now we can actually draw the parabola. We want to go to the vertex and curve down through the point on the focal width on the left. And then we're going to go back to the vertex. Then we're going to curve through the point on the focal width on the right. So our parabola is opening down and goes through the vertex and through the points on the focal width. Alright, here we have another equation that is not in standard form. So we have y squared minus 4y minus 8x minus 20 equals 0. So we have y being squared, and we have -4y. Those are both part of the variable that's being squared on the left-hand side. And we want to move everything else over to the right-hand side, because remember, our goal is standard form. So our goal then would be to have y minus k, quantity squared on the left-hand side. We want it to fit this form, equals 4a, and then the x minus h on the other side. So the first step to do that is to write y squared minus 4y. We want to keep everything that has to do with the family of variables that's being squared on the left-hand side. I'm going to put plus, always plus, and then I'm going to put a little blank line there, equals. We're going to move the other things to the other side. So anything that doesn't have to do with y, we're going to move to the other side. Now when we do that, we have to add. So we have to do the opposite of the sign that's in front of the term. So I have to add that to both sides. And add that to both sides. Okay, so on the right-hand side, we have plus 8x. Be careful with your signs here. They can really mess everything up. Plus 20, and then I'm going to put plus a blank. Because remember, when we complete the square, we're going to have to add that into both sides. So the first step is to kind of organize and set up the problem. Step 2, we're going to complete the square. So completing the square means you look to the linear term. So not the one that's being squared, but the term that just has the variable to the power of 1. That's called the linear term. We're going to take that and we're going to half it. That means we're going to divide it by 2. -4 divided by 2, that's -2. Now we're going to square it. -2 squared is a +4. This number always turns out to be positive, and I'm going to put that on both blanks, and I'm going to put that in both blanks because if I add a 4 to the left side of an equation, I also have to add a 4 to the right side to keep things balanced. Alright, so now we're going to look to the left-hand side and we're going to factor that. So we're going to factor the left-hand side. Alright, so if you were to try to factor that, that would be y minus 2 times y minus 2. Better way to write that is y minus 2 quantity squared. Something that is always going to happen, and so I'm going to go ahead and just mention it here, is the half you took. So the number you got when you halved it, the half you took, will always be the same number inside of the parentheses that are being squared. Those two numbers are always going to be the same. So you don't have to go through this factoring process if you know that when you have the half, whatever half you took, whatever that number is after you halved it, that's going to be the number with the variable inside of the parentheses that's being squared. So that's going to happen every time. You can jump straight from here to here. That's fine. Alright, so on the right-hand side, we end up with 20 plus 4. We need to combine those like terms. So 8x plus 24. And we're going to factor out whatever number is in front of the variable. So we're going to factor out an 8. Essentially, that means you're going to divide out by that number. We're going to pull that number to the front. And 8 divided by 8 is x. 24 divided by 8 gives me a positive 3. So here's our equation now in standard form. Now what we want to be able to do is to be able to look at that equation and tell what is the orientation, what is the vertex, what is the focus, what is the equation of the directrix, and then also be able to graph it. Okay, so let's start with the vertex. Be really careful, you might be tempted to say 2, negative 3. But remember, the x value always comes first. So it's going to be negative 3, positive 2. And remember, when you do take out the numbers, they change signs when they go in and when they come out. Okay, what about the orientation? Let's go ahead and do that. The y is being squared. The x is not. Both sides are positive. So that means that the graph will be opening to the right. And we will have a horizontal axis of symmetry. So we know a lot of information. Do we know the a value? How about that? Okay, so the a value always comes from the number that's in front of the parentheses that are not being squared. Remember, that is always the 4a. So we know that 4a is equal to the number in front of the parentheses not being squared. So that means 4a is equal to 8. So the focal width is 8. Divide both sides by 4, and that tells us that the a value is 2. Okay, so we have a lot of information. I think we have everything we need to come to our graph and graph the parabola. So I'm going to label. Alright, so now let's graph. The vertex is negative 3, positive 2. Let's plot that. Put a V. The next thing I'm going to go ahead and do is I'm going to go ahead and sketch out the axis of symmetry, which is horizontal. Okay, once I have that, now I should be able to come up with the focus. So the focus is going to lay on the axis of symmetry. It has to lay inside of the parabola. So since the parabola, we said over here, opens to the right, then the focus has to be to the right of the vertex. How far to the right? Well, we said the a value is 2, so we'll go 2 units to the right. And there's our focus. the focus is going to be labeled -1, 2. So -1, comma 2. So that means that the directrix will be 2 units to the left of the vertex and has to be vertical. So remember, the axis of symmetry and the directrix are always opposite of each other. So go 2 units to the left of the vertex and draw a vertical line there, and there is our directrix. Okay, what is the equation of the directrix? Well, it's a vertical line, so we'll say x equals. Every time I draw a vertical line, or given the equation of a vertical line, it's always x equals. What's the x value of that line? Well, it looks like it crosses at -5. Okay. Alright, so the last thing we need is to find the points on the focal width. Alright, so we said the focal width was 8. So 8 units long. So I'm going to go to the focus, and I'm going to go up 1, 2, 3, 4 units up. I'm going to go half the focus up. So whatever that focal width is, I'm going to half it. I'm going to go that much up from the focus. Let's see, can I label that? What would that be? -1, comma, what's the y value? 6. Okay, remember, use graph paper. Just look at the labeling on the graph. So the x value of that point that I plotted was -6. The y value, sorry, -1. The y value was a +6. Now I'm going to go back to the focus. I'm going to go down 1, 2, 3, 4. And I'm going to plot that point. Kind of covered up my negative there, so I'll just go ahead and put it back on there. Okay, so I'll go down 4 units. Can we label that? Remember, I'm just using the value straight off my graph paper. The x value of that point is -1. The y value of that point is -2. So I have 2 points, and I should be able to label them for my focal width. Alright, so now we can actually graph the parabola. You're going to go to the vertex, curve up through the point on the focal width, go back to the vertex, curve down through the other point on the focal width. Alright, so now we have the graph, we have the point on the focal width, we have the equation of our parabola, we have the vertex, focus, and the directrix.